this way. Okay, it's a little bit different than the positives. So if we think negative 0.58, well, that's almost 0.6. We're going to go ahead and put that one right here. And then that exact answer is negative 7/12. Now, if we look at 9/14, that's negative 0.64. We go to the left again of our 0.6. It's about halfway. Put our dot there, and then we get negative 9/14. Yeah. So that's 29. Any questions on that? Okay, the next one we're going to look at is we're going to graph the golf scores. So this is the word problem. We had several golfers. Now in golf, it's a little bit different. You want the low score in golf. So if you have the low score, that's when you're doing the best. So we have 6 golfers here, and their scores range from one person had a negative 16, which is awesome, a great score. And then one had I think that's a negative 9. Miss Kane, can you see, was that 9 supposed to be negative for the homework?
Let's see here.
Yeah. For AS?
Yes. Yes.
Okay, thank you.
The 2 and the 6 are positive. Yeah.
Perfect. So if you look at how I labeled the graph, I went from negative 16 all the way to a positive 6. And I went in every 2. For some reason, this Adobe doesn't want to save what I wrote on there. I apologize. So the first one we're going to look at is the SRP is a negative 12. So I'm going to put a dot, and we can just put the player SRP. AS is at 2. MW is negative 15, so that would be between the 14 and 16. We have another AS, so I'll put this one as AS2, and that's going to be a negative 9, so that's going to be between the 8 and the 10. We have KW is going to be negative 16. And then lastly, we have MM, which is a positive 6. So the big thing for these is setting up your number line. If you notice, just by looking at the numbers, we saw the range is positive 6 all the way to negative 16. And so I decided to go with every 2. Each one was worth 2. If you could do each one's worth 3 for each dash, you could do each one's worth 4, each one's worth 5. But for this one, I think the best one would be each one's worth 2. Any questions on that one? And then lastly, we have what is the quotient of negative 5 and negative 5/3? Oop. All right. Okay, when we say quotient, we're going to think about division. So how to write this would be negative 5 divided by negative 5/3. Now, an operation, if you remember from algebra, is when you're dividing a fraction, you can multiply it by its reciprocal, which is a goofy word. So what we'll do is, that's the same thing as saying negative 5 times, and now does anybody know what the reciprocal of negative 5/3 is? Somebody want to help us out with the reciprocal?
Michael, do you think you could tell us what the reciprocal of negative 5/3 is?
I have no clue.
No clue?
No.
And it looks like Mr. King, I think the negative 5 should be negative 15.
Oh, they get deleted.
Yeah, that's all right.
Sorry. This is sorry about that.
No, it's all right.
So it's negative 15/3.
No, the other way around.
Oh,
Negative 15 and negative 5/3.
got you.
There we go.
Thank you. Adobe just doesn't want to save what I wrote before, so sorry.
It's all right.
So the reciprocal is just, you flip it around. So the negative 5/3, we're going to move the 3 to the top, and then the 5 to the bottom. So now we can just go ahead and we can just do some straight across multiplication. Negative 15 times negative 3 is going to give us a negative gives us a positive 45. And that's going to be over 5. Because this is the same thing as a 15 over 1. So if you multiply across 15 times 3 is 45. 1 times 5 is 5. And then lastly, you're going to take 45 divided by 5. And that's going to give your final answer of 9. Does anybody have any other questions about the homework that we could go over before we get into PEMDAS? Okay. Let me unshare.
All right, so you will want to take out your calculator because we're going to be using the calculator. So if you have your calculator, pull that out so that it's next to you. Because we're going to talk about using that calculator a little bit. And I'm going to show you on my calculator how we'll use that. We are going to skip the warm-up again. So we skipped it yesterday. We're going to skip it again today. Woohoo! No warm-up problem. The first couple of problems that we're going to look at, though, consist of talking about a power. So today we're doing two things. We're going to talk about powers, and we're going to talk about order of operations. So we have this 7 cubed. That's what we're looking at right here. The whole thing is called a power. But there are actually two parts to this power. There's the 3, and then there's the big 7. The big 7 is called the base. That's the big number that we're applying that 3 to. So the big number is the base. The little number at the top, that's called the exponent. But the whole thing together is actually called the power. So 7 cubed is a power. It has an exponent of 3. So we're going to try and evaluate these powers. And I want us to look at the difference between A and B. So we're going to go to the calculator so that we can kind of see the difference between those two. So I pulled up my calculator here. And letter A says -2 to the 4th. So I'm going to type in the -2 first. And those of you that have the graphing calculator, you can type it in this way. If you have another calculator, just type it in this exact same way. And then I need you to look for the exponent button on your calculator. My exponent button is a little caret symbol. So that's where mine is, right here. And I'm placing a 4 in because the exponent is 4. So this is exactly what it says on my page. My page says -2 to the 4th. And then when I hit enter, I get -16. So that's the answer for letter A. Letter B is different because it has parentheses. So on my calculator, I'm going to place parentheses. And then I'm going to hit -2, and end my parentheses. Still using the caret, and I'm using a 4. So you can see the difference between the two problems, parentheses versus no parentheses. And I'm going to hit enter again, and I get a positive 16. So see if you can try that in your calculator. I'm going to go back to my screen and explain why that is happening. So that you can kind of understand what the difference between the two problems are. So the first problem says -2 to the 4th. So that has a negative sign, and then it's taking 2 and multiplying it together 4 times. That's what a power means. The exponent is 4, so I'm really multiplying that number together 4 times. When I do that, I get -16. And if you don't have a graph and calculator, that's what you're going to place in your calculator. -2 times 2 times 2 times 2. For letter B, this one, we're taking the whole number -2 and multiplying it together 4 times. So we're taking -2 times -2 times -2 times -2. So we're going to multiply that together 4 times. So you can see the difference with the way I would write it out. And when I do that, -2 times -2 is 4. -2 times -2 is 4. Because a negative times a negative makes a positive. And that's how we get a positive 16. So what I'd like you to do on your calculator, see if you can type in the rest of the problems, C through H. If you want to write it out, you can. So letter C would be -13 times 13. Whereas letter D is -13 times -13. So notice parentheses, no parentheses. So see if you can take and place those other 6 numbers in your calculator. Good time to find your calculator or pull out your phone maybe to use the calculator app on your phone. But when you come to math class, you're going to need a calculator every single day. So Bill, can you tell me what you have for C versus D in these problems? What did you get for C?
-169.
And then what did you get for D?
+169.
Nice job. Perfect. So we can see the difference between parentheses and no parentheses in those two problems. In letter E, 4 cubed is really taking 4 times 4 times 4. Emma, do you know what 4 times 4 times 4 is?
$12, but how do you do like parentheses on this one? Because my calculator died.
Your calculator died?
Yeah. With the battery.
Okay, so if you just have just like a regular phone calculator, you would just type in 4 times 4 times 4. So you would type it in 3 times. Or your iPad might have a calculator on it as well. If you go to like the app area, you can just type in calculator, and there's probably a calculator that's already in your iPad. But how I have it written on the screen, you could just type it in your calculator exactly like that. So for
it doesn't matter, like for parentheses.
Right.
Okay.
So if you look at letter F, I could really just type that in as -3 times -3.
Okay.
So letter E should be 64. Letter F should be 9. And then for letter G, this one's the one without parentheses. So I would write negative, and then I'm just typing in 3. So if there's parentheses, you're writing the entire number inside the parentheses. You're typing that in exactly as it's listed 2 times. If there's no parentheses, then it's 1 negative sign out front, and then the number separate 3 times. So this would be negative 27. And then letter H would just be the number 2. Any number to the first power is the number itself. So if you didn't have a calculator with you today, make sure you bring one tomorrow because we will be using that every day. Or find the calculator in the apps of your iPad, or use the calculator on your phone. Remember, you don't need a fancy graphing calculator. You can just have a regular plain old dollar calculator from the dollar store. Any type of calculator really will do for what we're going to be using it right now.
iPhone calculator is a little bit tricky with parentheses because it doesn't show you what's left on there, but it still does work if you type in everything correctly. The problem is you won't be able to see everything that you write on there. There's a lot of good calculators online. I think it's a little bit easier. Like once we get off the Zoom, when you're working on your homework, maybe you could just type one in, a scientific calculator online, and then that'll pop up because they'll let you see the parentheses that are written in.
So you don't necessarily need the app, as Mr. King was explaining. You could just go to your web browser and type in scientific calculator, and a free one will come up for you to use. All right, so we are going to go over a definition, and then we're going to look at a few problems. We have the word numerical expression, and a numerical expression consists of numbers, operations. An operation in math is an addition sign, a subtraction sign, a multiplication sign, a division sign. Those are operations. And then grouping symbols. Grouping symbols are parentheses. We may also have exponents. So an expression really is like a list of numbers that are being added or subtracted or multiplied together. So we're talking about order of operations, and order of operations uses the word PEMDAS, which I think you have heard many times. Does anybody remember what the P stands for in PEMDAS?
Parentheses.
Yeah, perfect, parentheses. So step 1, perform operations that occur within a parentheses. How about the E? What's the E stand for? Somebody
Exponents.
Exponents, nice. So the second step is to evaluate the exponents. So parentheses and exponents. The third step, what does the M and the D stand for?
Multiplication, division.
Perfect, nice, Michael. Multiplication and division. Now, this one's weird. It says perform multiplication and blank. So Michael just said division. So we're performing multiplications and divisions from blank. And there's a way to perform them, and it's from left to right. So when we're doing multiplication and division, we do them actually the way you read a book, where we read words from left to right. And then the A and the D, or the A and the S, what would the A and the S stand for?
Addition and subtraction.
Excellent, addition and subtraction. Perform addition and subtraction, again from left to right. So PEMDAS helps us simplify an expression. It gives us a direction as to what to follow when we're working through a problem. And we have two really good problems that we're going to go over, and just these two, and then we're done for today. So we did a couple of examples with powers. Now we're going to do two examples with using PEMDAS. And I'm going to write PEMDAS above here in my note packet to remind me what I'm supposed to do first. I need to see steps when you're working through this so that I can kind of know that you understand the process of PEMDAS. So you're going to have multiple steps as we work through these problems. So the first thing is P. We said it was parentheses. That means I need to go in the middle of the parentheses, which is right here, underlining it, and I need to combine those numbers in the parentheses. So I have 36 divided by 4. I have a times symbol, and then inside the parentheses, I'm going to add -1 plus 4. Josh, what is -1 plus 4?
It's 3.
Perfect. Great, Josh. Since you're still on with me, now we're going to do the exponent. And the exponent is 3 squared. What is 3 squared, Josh? 3 times
It's 9.
Excellent, 9. So now we have 36 divided by 4. Keeping the times sign, 3 squared becomes 9. Notice how I underline each piece that I'm doing. And then I change that piece. So now the next step, multiplication and division from left to right. Well, if I'm reading from left to right, I have to divide these two numbers first because they're on the left side. So we have 36 divided by 4. Does anybody know what 36 divided by 4 is?
9.
Yeah, Emma said 9. And then Emma, the last step is to multiply 9 times 9. So you know what 9 times 9 is?
81.
Perfect, nice job. So following order of operations, we did all of the steps and we got 81. So we're going to do one more problem. It looks almost the same. We're going to follow the exact same steps of the order of operations. And we should be able to then break down and get it down to one number. So following PEMDAS again, parentheses first. Here's my parentheses. Underlining the part that I'm working on. So parentheses means do the stuff in the middle. -2 plus 5 is 3. All right, now we go to the E for exponents. Haley, do you know what 3 squared is?
9.
Yeah, perfect. So 24 divided by 8 times 9. And then Haley, since hopefully you're still here with me, division,
Yes.
24 divided by 8 is?
3.
And then finally 3 times 9 makes?
27.
Perfect. Awesome job. So we have two examples there where we're using that PEMDAS order of operations. So it is 11:15. You have 15 minutes in class time now that you can start your homework. Before I let you go, are there questions that anybody has on what we did today with exponents or PEMDAS? And I will send out a link to one of the web versions of a calculator. I will put that directly into the comment section of Google Classroom into the stream, and then that'll be there for us to use. So I'm going to go back to my initial slide just to remind you what the homework is. So it's pages 12 and 13 in your book. It's 25 to 53. This is also posted in Google Classroom. Please make sure you write the original problem down and show work. You have to have work in order to receive credit for math, because in math, the process is more important than the answer. So I need to see how you're getting to that answer. Does anyone have questions?
I have a question.
Yes, Michael.
Is it okay if I just write down the homework just on a piece of paper and then just take a picture and send it to you through Google Classroom?
Yes, definitely. And for
Okay.
all of you, if you just want to write the homework down on a piece of paper and then take a picture and post it to Google Classroom, that is fine. You don't have to do your homework on a notability slide. Not at all.
Okay.
Yep,
Thank you.
so, all of you can do that. If you'd rather just do your homework on paper, because I mean, it's in the book, so you can do your homework on paper and then just take a picture of it and post it to Google Classroom. And if that's what you did last night too, that's perfect. No problems with that. Any other questions? Mr. King, did you have anything that I missed?
No, I think that's good. The big thing is finding a calculator that you're happy with. I would try a different couple online. Make sure you get familiar with yours, because it does get a little confusing putting into parentheses and different things like that. But once you find one, I think that you'll do real well.
All right, so all of you have a great day. Thanks for joining us today. Again, if you want to stay on because you have questions, feel free, because we're here till 11:30. Otherwise, you can start working on your homework. You've got about 15 minutes left in our class time. Have a good day.
Where do we submit like today's homework? Because I only see like last night's.
So today's homework, I need to change it. It didn't pop up yet.
Okay.
That's why.
Good call, Emma.
Thank you.
Okay, it'll pop up in 2 minutes.
Okay.
I have it posted for too late.
Okay.
So it'll be on there in a minute or two.
Okay.
Thank you, Emma.
Thank you.
Make sure I change that. Anyone else have questions?
Nate or Zach?
I have no clue what I'm doing.
Okay, you want me to work with you, bub?
Hold up. I keep getting these texts from my friends, and apparently someone's bullying them. So I had to keep track on that. Sorry, but I will need help with this. I know we're doing something along the lines of PENDOS, right?
That's exactly what we're doing.
Yeah, I remember I answered that. And then, what is the thing that we first started with? Like that, mute that. What were we doing with before we did the exponent things?
With the number line, graphing on a number line,
Yeah,
that was what we did yesterday.
okay.
So yesterday we took notes. I have them up on the screen. We were graphing on a number line. So we were converting the numbers to decimals and then plotting the points on a number line. And that's posted in yesterday's assignment on Google Classroom. And there's a video that you can watch as well.
Okay, thank you.